We are not afraid to entrust the people with unpleasant facts, foreign ideas, alien philosophies, and competitive values.
And now for something completely different.
For a nation that is afraid to let its people judge the truth and falsehood in an open market, it is a nation that is afraid of its people.
Completely different.
Tantalizing evidence for new physics from Cern's Large Hadron Collider. In March, particle researchers presented intriguing evidence for fresh physics, potentially a new force of nature, at the Large Hadron Collider, LHC. Now, a new result from Cern's Massive Particle Collider, which has yet to be peer-reviewed, appears to be supporting the theory. The Standard Model is our current best theory of particles and forces, and it accurately represents what they know about the physical material that makes up the world around us. The Standard Model is, without a doubt, the most successful scientific theory ever written down, and yet at the same time, we know it must be incomplete. Famously, it describes only 3 of the 4 fundamental forces, the electromagnetic force, and strong and weak forces, leaving out gravity. It has no explanation for the dark matter that astronomy tells us dominates the universe, and cannot explain how matter survived during the Big Bang. Most physicists are therefore confident that there must be more cosmic ingredients yet to be discovered, and studying a variety of fundamental particles known as beauty quarks is a particularly promising way to get hints of what else might be out there. Beauty quarks, also known as bottom quarks, are fundamental particles that combine to form larger particles. Quarks are classified into 6 flavors: up, down, weird, charm, beauty, bottom, and truth, also referred to as top. Up and down quarks, for example, make up the protons and neutrons in the atomic nucleus. Beauty quarks are unstable, living on average just for about 1.5 trillionths of a second before decaying into other particles. The way beauty quarks decay can be strongly influenced by the existence of other fundamental particles or forces. When a beauty quark decays, it transforms into a set of lighter particles, such as electrons, through the influence of the weak force. One way a new force of nature can reveal itself to us is by modifying the frequency with which beauty quarks decay into different types of particles. The March paper was based on data from the LHCb experiment, one of 4 giant particle detectors that record the outcome of the ultra-high energy collisions produced by the LHC. The B in LHCb stands for beauty. It found that beauty quarks were decaying into electrons and their heavier cousins called muons at different rates. This was surprising because the muon, according to the conventional model, is essentially a carbon copy of the electron, except that it is roughly 200 times heavier. This means that all forces should exert the same amount of force on electrons and muons. When a beauty quark decays into electrons or muons via the weak force, it should do so equally frequently. Instead, they found that the muon decay was only happening about 85% as often as the electron decay. Assuming the result is correct, the only way to explain such an effect would be if some new force of nature that pulls on electrons and muons differently is interfering with how beauty quarks decay. The result caused huge excitement among particle physicists. They have been searching for signs of something beyond the Standard Model for decades, and despite 10 years of work at the LHC, nothing conclusive has been found so far. So discovering a new force of nature would be a huge deal, and could finally open the door to answering some of the deepest mysteries facing modern science. While the result was tantalizing, it wasn't conclusive. All measurements come with a certain degree of uncertainty or error. In this case, there was only around a 1 in 1,000 chance that the result was down to a random statistical wobble, or 3 sigma as they say in particle physics parlance. 1 out of 1,000 may not seem like a lot, but in particle physics, they make a lot of measurements, so you may expect a tiny number of outliers to appear by chance. To be really sure that the effect is real, they would need to get to 5 sigma, corresponding to less than a 1 in a million chance of the effect being down to a cruel statistical fluke. To get there, they need to reduce the size of the error, and to do this they need more data. One way to achieve this is simply to run the experiment for longer, and record more decays. The LHCb experiment is currently being updated so that it will be able to capture collisions at a much faster rate in the future, allowing for far more exact observations. But they can also get useful information out of the data they have already recorded, by looking for similar types of decays that are harder to spot. This is exactly what they have done. Strictly speaking, they have never actually studied beauty quark decays directly, since all quarks are always bound together with other quarks to make larger particles. The March study looked at beauty quarks that were paired up with up quarks. Their findings looked at 2 decays, one in which the beauty quarks were associated with down quarks, and another in which they were linked with up quarks. The fact that the pairing is different shouldn't matter, the degradation going on deep below is the same, and they would expect to see the same result if there is a new force out there. And that is exactly what they have seen. This time, muon decays were only happening around 70% as often as the electron decays, but with a larger error, meaning that the result is about 2 sigmas from the standard model, around a 2 in 100 chance of being a statistical anomaly. This means that, while the result isn't precise enough to claim clear proof for a new force on its own, it does align extremely closely with the prior result, adding to the sense that they are on the verge of a significant breakthrough. Of course, they really should be cautious. There is still some way to go before they can claim, with a degree of certainty, that they really are seeing the influence of a fifth force of nature. The physicists are currently working hard to squeeze as much information as possible out of the existing data, while busily preparing for the first run of the upgraded LHCb experiment. Meanwhile, other experiments at the LHC, as well as the Bell 2 experiment in Japan, are closing in on the same measurements. It's exciting to think that in the next few months or years, a new window could be opened on the most fundamental ingredients of our universe. We would like to know what you think. So leave us a comment below, and hit the subscribe button for the latest videos from the Raw News. Don't forget to hit the bell to receive update notifications. As always, thank you for watching. God bless everyone, and remember, the truth is out there, never stop searching.
Reality is merely an illusion. What remains is the raw, shocking, humiliating truth at the bottom.
And now for something completely different.
The truth is out there. Never stop searching. boson,
Proceed to exit.
Facebook, Twitter, YouTube. If it's not the wrong news, it's just completely different. Subscribe today because I like it raw.